So today we're going to learn about solving for a variable, or solving for x is what a lot of people say. So the first thing you need to know is you need to know what an operation is. So write this down. Operation. An operation is pretty much, there's four types of operations. You've got addition, subtraction, multiplication, division. Now, the next thing you need to know is inverse operation. So what do you think the word inverse means? I'm hoping you mean like the opposite of something. So an inverse operation is the opposite of the operation that you have, or the operation that undoes it. So if we've got addition, what do you think the inverse operation is for addition is? Subtraction. And what do you think the inverse operation is for multiplication? Right. Division. And therefore, division is, the inverse operation of division is multiplication, and the inverse operation of subtraction is addition, okay? So let's go ahead and take a look at a couple of things. So the first thing that we need to do when we are solving for a variable is, one, we need to isolate the variable. And how do we do that? We use inverse operations, okay? And again, you need to, in order to do the inverse operations, you need to recognize what operations are there. So if you have let's take a look here real fast. If you have a fraction, like 1/2, for example, this is what type of operation? It's division, because we really just have 1 divided by 2, okay? And if we have a coefficient and a variable next to each other, like 2x, what operation is happening here? It's multiplication. There's an invisible tiny little dot here saying that we need to multiply, okay? And so when there is a coefficient, which is the number next to a variable, that means there's multiplication. It's 2 times x, but the multiplication sign is invisible. So it's important for you to realize this when solving for a variable. If you see a fraction, you know that it's division, so what's the inverse operation you're going to use? Multiplication. And if you see 2x, you know that the operation that's happening here is multiplication. So what's the inverse operation you're going to use? Division. Exactly. All right, so let's go back to the notes, and you need to write down that fractions equal fractions. This is the division operation. Coefficient next to a variable is the operation of multiplication, okay? Put that in your notes, and let's go back. So take a look here. If we have, let's see here, 3x, or no, I'm sorry, we're going to do it this way. If we have x plus 3 equals 9, okay? The first thing we have to do is remember what a variable is? A variable, and this should be in your notes, a variable is a symbol that represents something we do not know. And a variable can be anything except for a number, because the variable represents a value that we don't know. So x has a value, but we don't know what the value is yet until we solve for it, okay? So it's important that you understand what the term variable means. The next part is, what is this? This is an equal sign, a little bit of a crooked equal sign, but it's an equal sign. So what does the equal sign mean? The equal sign means that everything on this side is equal to everything on this side. It means both sides are equal. So if we have a scale, which side would be higher and which side would be lower if this equal sign represented a scale with two sides? Right, it would be exactly even. One side wouldn't be higher or lower because both sides are even, okay? So that's what you need to remember. When you see an equal sign, it means that this side, everything on this side, equals the value of everything on this side, okay? So let's take a look here. I have x, and I want to get it by itself. How do I do that? Remember, we said in order to isolate the variable, we use inverse operations. Another way to look at that is, what if we get rid of the another way to look at this is I have x and then I have 3. Let's pretend like these are 3 oranges. So if I have x and I have 3 oranges, how do I get rid of the 3 oranges? That's right. I have to subtract or take away the 3 oranges. So I'm going to subtract the 3 oranges, okay? What does that make it? 3 minus 3 equals 0, okay? Now, are both sides even now? I just made a change here. I subtracted 3 from this. Are both sides even now? They're not. So I have to do the same thing to the opposite side. So if I subtracted 3 here, I have to subtract 3 here. And then it'll make it even, right? So for example, if I've got 2 equals 2, that's right? 2 equals 2. And if I just decide, hey, let's add 3 to 2, so I've got 5 equals. Does 5 equal 2? It doesn't. So because I added 3 here, I've also got to add 3 here, okay? So 3 plus 2 is 5. So now, does 5 equal 5? It does. Again, and if I subtract 1 here, that would make this 4, but I have to do it to both sides, otherwise it's not going to be equal anymore. So minus 1, 5 minus 1 is 4. So now 4 equals 4. Is that true? It is. Okay, so that's why we got to do it on both sides, okay? So we have 9 minus 3 equals 6, okay? So now we're left with, if I bring everything down that I haven't done anything with yet, I've got x plus 0 equals 6, okay? Do I have to write the plus 0? I don't, okay? There's no reason to. So I'm just going to write x equals 6. Do you see what happened here? I got rid of the 3, putting the variable by itself, x by itself, and now I know what the value of x is. What's the value of x? It's 6. Now we want to check our answer to see if that's right. So if I think x equals 6, well, let's come up here and I'm going to erase x and write in 6 here, okay? So 6 plus 3 equals 9. Is that a true statement? It is, okay? So that is my answer, okay? So now I know that x does equal 6, okay? So let's go ahead and look at a few of these. So I'm going to erase everything. And this time, let's do n minus 4 equals 10, okay? So here, what's the first step? The first step is isolate the variable. How? Use the inverse operation. So what's the inverse operation here? I need to get rid of the 4. This is a minus 4. So how do I get rid of it? I'm going to add 4 because that'll make it 0, right? So I'm going to add 4. Now that I've added 4 to this side, are both sides equal? Nope. So I've got to add 4 here. Okay? So negative 4 plus 4 equals 0. 10 plus 4 equals 14. Bring down my n. And I don't have to write n plus 0, so I'm just going to write n equals 14. Is that my answer? Is that correct? Let's check it out, okay? So instead of n, I'm going to cross that out and write the value that I know n equals, which is 14. So 14 minus 4 equals 10. So that is true, okay? So now I have proven that my statement is correct. Let's do 2 more, okay? 3x equals 9, okay? 3x equals 9. So the first step is to isolate the variable. How am I going to isolate this variable? What does it say here? I've got to use the inverse operation. Well, first I got to know what operation is happening here. If you remember, we have a coefficient that's next to a variable. Our notes say that when a coefficient's next to a variable, the operation is multiplication, okay? So there's a tiny little multiplication invisible dot there, okay? So I've got 3 times x equals 9. So what's the inverse operation of multiplication? Division. So I'm going to go ahead and divide 3x by 3, okay? Now look at this. What is 3 divided by 3? It's 1, right? So this turns into 1x equals. Now remember, I just divided by 3 on this side. That means that this is no longer equal. So what do I have to do? I have to also divide by 3 over here. So let's 9 divided by 3. And again, this looks like a fraction because fractions equal division. So 9 divided by 3 equals 3. Do I have to write the 1x here? I do not, because when a coefficient is 1, it's invisible, okay? So now I've got the answer of x equals 3. Notice how I did that? I isolated the variable, so now it's all by itself, and that tells me that x equals 3. Now we need to check our answer. So I'm going to go ahead and cross out this x, and replace it with the value that I know, which is 3. So now I've got 3 times by 3 equals, what's 3 times 3? It's 9. So is 3 times 3 equals 9 a true statement? It is. So now I know that x does equal 3. So let's do one more, and then you should be ready to go, okay? And this is for division. So let's say we have s over 3 equals -9, okay? -9. So if I have this, what is the operation happening over here? I'll make sure this looks like an S and not a 5. I need to isolate this variable. How do I isolate the variable? I use inverse operations. So what operation is happening here? It's division, okay? Because it's a fraction. Fractions are division. This is s divided by 3. So what is the inverse operation of division? Multiplication. So that means I'm going to multiply by 3 because I want to get rid of it. So let's multiply 3 times by s. And because I'm multiplying by a fraction, I'm going to turn this 3 into a fraction. How do I do that? I put it over 1, because isn't 3 divided by 1 just 3? So it's the same thing. So when I multiply, I'm going to multiply it by a 3 over 1. And let's do it. So 3 times by s equals 3s. And 1 times by 3 equals 3. Okay? Now I've got a similar situation here. My 3 divided by 3 equals 1, right? So now I've got 1s. Do I have to write the 1? No. So I've just got s equals. Now, this side is now no longer equal to this side because I went and multiplied this side by 3. So I've got to multiply 9 by 3. What is negative 9 times by 3? It is negative 27. Okay, so negative 9 times by 3, bring that down here. Now I know s equals negative 27. So let's try it out, okay? We're going to go ahead and get rid of this s and write negative 27. So now we have negative 27 over 3 equals negative 9. Is that true? Well, take out your calculators. Negative 27 divided by 3, negative 9. It is. So now I know my answer is correct. Go ahead and keep practicing these. Make sure you review your notes as you go through these step by step, and this will be great.